looks good. Yeah.
Perfect. Thank you all so much for coming, and thank you Ocean Data Factory for inviting me to present our project, the PELADRONE, a digital innovation project that's co-funded by EEA grants. So getting straight to it. There we go. As we already know, a healthy ocean is essential for life on the planet, not only for its ecological importance, but a healthy ocean is needed to sustain multi-million-dollar industries and provide jobs. It is essential to provide food globally, directly from the ocean or transported through the ocean. And a healthy ocean also helps regulate our climate through the various current systems. And a healthy ocean supports the well-being of coastal communities globally. In fact, over 1 billion people worldwide are reliant on healthy oceans as a source of income and food, especially the world's poorest, which just underscores the urgent need for sustainable use. However, coastal communities and the ocean are at risk. It is estimated that 50% of the world's litter is produced by the fishing industry, which impacts marine ecosystems and their biomass. Ghost nets are trapping fish on the seabed, whilst ocean litter keeps fish from spawning, which further leads to further declines in fish stocks, which are already declining, and only hampers the search for fish. All of this has led to reduced competitiveness for small coastal fisheries, as they can't compete with the large-scale fisheries, and in turn leads to negative social impacts for these coastal communities. Which leads also the younger generations to go to large cities in search of better job opportunities, creating vast negative social impacts. And with this, although efforts has been made to rejuvenate these areas through tourism, this is all very seasonal and ends up driving the housing prices up, which pushes the locals out of these communities, and thus not a sustainable approach. But it's this reduced competitiveness that has really caught our attention, as although efforts underway to tackle many of these challenges, it is the reduced competitiveness that we sought to resolve, so that to create sustainable coastal communities, which will in turn lead to sustainable ocean use. And it's the increased investment in automation in these large-scale fisheries that has led to a lot of this discrepancy in competition. Their access to new technologies has allowed for innovative automation systems, but they're only available to those that can afford it. Therefore, the large-scale fisheries and not the little coastal guys. With this, small coastal fishermen spend over 45% of their time searching for fish. And with the continuous declines in stock, this time will only increase. With increasing time leads to ever-increasing costs and making their work less effective and less efficient. It's with this in mind that we began Peniche Ocean Watch, with a vision to develop a pilot blue circular economy model that we can share globally and empower coastal communities through a digital entrepreneurial mindset. With this model, we hope to facilitate knowledge sharing, provide entrepreneurial opportunities, but most importantly, develop ocean-based technologies to tackle some of the ocean's biggest challenges. And as our first project within this circular economy is our PELADRONE project, this digital innovation project, which seeks to transform coastal fisheries. And we are launching our pilot in Peniche. Why Peniche? Peniche is a coastal fishing town about an hour north of Lisbon. It's home to about 27,000 people, and it's one of the few remaining fishing ports still in operation in Portugal today, with about 600 fishermen currently active, which makes it an ideal situation to test these kinds of technologies and really which makes it the ideal situation to test these technologies. To date, coastal fishermen, as I said, spend about 45% of their time searching for fish along the coast, and they zigzag, not knowing exactly where the fish is. At times they miss the fish, other times they only know what they've caught once they've brought it up. And sometimes it might be fish that's out of season, which turns this kind of fishing very unsustainable if they have to throw back their catch. And so, with this in mind, in collaboration with partners in Norway, Birdview and Borgenecki, We are developing a drone which will facilitate this operation. Patented drone technology, which will deploy a sensor into the water to detect where the fish is. With this, we will create an information service. As you can see here on the left-hand side, the drone will be operating, searching for fish along the coast, and it'll communicate this information to an information center, which will then communicate this further to our clients, the fishermen, the coastal fishermen, who can then plan their day and their fishing routes. So as demonstrated here, our PELADRONE solution, with the drone actively going out, being guided by a pilot and a land-based fisherman to detect where schools of fish are. With this information at hand, fishermen can then plan where to go directly to the fishing spots. Not only this, but we hope with machine learning algorithms in the very near future to be able to detect not only what kind of species it is, estimate the biomass of that catch, and the estimated value of the catch for better informed decisions and making sure that the fishermen catch fish that are in season and that are allowed to be caught, but also choose the most sustainable catch possible. By providing this PELADRONE solution, we hope to reduce the fishermen's search time by over 50%. Not only this, with the reduced search time, will also lead to reduced fuel costs and reduced emissions. By reducing their time out at sea will also increase their safety. Right now, the fishermen as they're so reliant on these fishing catches, they have to go out in very perilous conditions just to ensure that they catch some fish, as this is their main source of livelihood. And so by increasing both their safety and reducing their costs, we hope to increase the competitiveness of these coastal fisheries. And so how will this work? As I previously demonstrated before, the drone will be operating, searching for fish. It'll communicate with a ground station where a pilot will guide it to the various locations. It'll then transfer the information that it's produced, that it collects, to a server, populate it with various types of data. Right now, we'll be deploying an echo sounder and hope that with further funding availability, we'll be able to improve the sensors that the drone can deploy. And so as it feeds this server with various types of data, we'll communicate to the ground station and we'll be able to select which spots we would like the drone to go next. But how will the fishermen be able to access this? Well, with that, we're producing an application, a layer that we'll be able to provide on a fisherman's phone or tablet, or any kind of customer's phone or tablet, where they'll be able to view the drone results. This front-end application that we're developing will have a guided map, and we'll request these data from our partners in BirdView and communicate it back and forth and populate what I'm most excited about, our data storage, where we'll be able to produce algorithms to turn this system or the detection system autonomous, but also create an ocean data bank with various data sources. As in the future, we hope to not only be limited to drones, but to have various data sources coming in to better create this machine learning algorithm and enhance the artificial intelligence aspect of the project. As said, fishermen will be able to see an application sort of like this, a sea map, which will tell them where their catches, where the drone has detected schools of fish. And by selecting which school of fish they would like to see, they will then get further information about that catch, be it the type of species that it is, the quality of the fish that's caught, that it detected, so whether it's juvenile or whether it's adult, whether it's in season to be caught or not in season to be caught, and link it to current market prices. They can get an estimated value of the catch that's there, instead of having to wander around aimlessly looking for these different types of catches. However, this isn't just dedicated to fisheries, and in fact, this technology has many uses beyond fisheries. The drone will also be equipped with a camera And by having both the underwater sensors and the above the water surface sensors, we'll be able to better inform marine protected areas and thus allow government and researchers to see where the different biodiversity hotspots are, not just in fish to be fished, but also sharks and all the various marine biodiversity out there. Again, with marine protected areas, various biodiversity monitoring to see what areas should be better used, should be limited use in certain times of the year, and what other areas are okay to be used both recreationally and for industry. But also ocean litter mapping with a drone, as the drone will be able to detect everything within the water column. One of our main adjacent projects to this is that not only will the drone be able to detect biodiversity, but it'll be able to detect ocean litter around so that the fishermen, once they've caught their catch for the day, can then begin catching and fishing for ocean litter, turning this waste into a material of value. And also in general, maritime mapping to see what is on the seafloor, what kind of embedded litter is on the seafloor, what kind of reefs and species that we weren't previously aware of within our coastal waters. So where are we now along this project? So we started in January with the EEA funding, and we've come a long way since then with lots of back and forths and workshops and permits and licensing. And we are now at the stage of developing this interface platform for the fishermen. And so doing a lot of the research around that for user experience. We have our first test flight for the end of March, beginning of April, where we'll be able to see just the extent of the drone capabilities and how and what type of data we'll be able to get back and really perfect the data quality and operational quality of the drone. And hopefully we'll have a proof of concept flight and finalized drone flights in this summer. And so I'll have to come back and let you guys know how the test flights have gone and how our preliminary results have gone. And as I said before, this is part of a larger economic model, not just the drone for mapping the coastal waters, but really creating an ecosystem of ocean technology in Peniche. We're very well surrounded by maritime industry and universities in the Peniche area. And so it's a very fertile ground for idealization and co-creation around these issues of the ocean. We have a small but growing team that's dedicated to these projects. And so feel free to reach out to any one of them. And yeah, I've spoken far quicker than when I practiced this talk, but this is how you can get in touch with us and keep up to date with what's going on in the project. And yes, and I would like to show you our film, but I'll have to stop sharing and reshare a different screen. And so,
and Mafalda, make sure you share your computer sound so we can hear it.
Yes, yeah, of course.
Sometimes it's easy to forget that.
Let me just, apologies if I spoke very quickly, everybody.
There's also some questions in the chat, but we can take those after the film. Yeah.
So, share sound. Your speaker is not working.
I don't have an answer for that. Is there something else I can help with?
There we go. You all heard that, right?
Yeah, we heard that. So it's definitely working.
It's definitely working. So you can see the main screen?
Yes. Yes. So give it a go. If not, I might be able to.
Part of the Peniche Ocean Watch initiative by Ocean Tech Hub, LDA. Fishing has long defined the livelihoods of coastal communities in Portugal, with 90% of the industry made up of small to medium-sized fisheries. Yet these fisheries are at risk. Increased investment in automation by large-scale fisheries is driving down competitiveness. Ocean litter continues to threaten marine ecosystems, reducing fish biomass. And reduced opportunities are pushing younger generations to city-based industries, casting doubt over the future of coastal communities. With this in mind, we developed PELADRONE, an innovation project that combines state-of-the-art digital technologies to streamline the process of locating and catching pelagic fish. Together with our partners, the PELADRONE project will develop an information service that will equip fishermen with the location and quantities of nearest catches, using patented drone technology specifically adapted to Portuguese maritime conditions provided by our partner Birdview. The PELADRONE service will combine artificial intelligence to search for surface-related indicators and use marine scanning devices to identify the biomass below the surface. By increasing search ranges and identification accuracy, we will reduce fishermen's time at sea, their risk, emissions, and costs, strengthening the competitiveness of their work. The drones will also map coastal waters, providing vital information on extent, location, and type of subsurface waste, a problem which presently costs the Portuguese fisheries 60 million euros. Through a blue circular economy model and bilateral relations among Portugal, Norway, and Sweden, the PELADRONE project seeks to digitally transform coastal communities, bringing in new skills and opportunities that lead to thriving, sustainable futures. As one of the few remaining fishing ports in operation in Portugal, the coastal town of Peniche will be the setting for our first implementation. A fishing community with unique opportunities, fishing has shaped life here for centuries, with some 600 fishermen still active despite a number of economic and social challenges. With its extensive fishing knowledge and strong entrepreneurial mindset, Peniche presents a solid base for future development and the ideal launching point for the PELADRONE project. Co-funded by EEA and Norway grants.
Okay.
Thank you, Mafalda. Yeah,
No, thank you.
very impressive video. we already got some questions from our audience.
Yeah.
So maybe let me read out them. Yeah. So
Sure.
the first question from Juicy: how many drones fly at the same time? And also another question: what is the flying time per drone?
Okay. Well, so in terms of how many drones fly at the same time, right now it'll just be one because it's a proof of concept project, and so we're only developing one drone. But the idea would then be to have a fleet of drones along the coast, each flying at different ports, and numerous drones can fly within the same port as well, so they can fly in tandem. As one is flying, the other refueling, and then they swap. And so that is a possibility, a future possibility, but funding dependent. And so that's in terms of the drone. And then the flying time per drone. Right now, it's about an hour operational time at 16-kilometer distance, because it's a hybrid engine, so it has both electrical and diesel powered. And so the electrical part of the battery is it's for backup. And so again, funding dependent, we want to increase the operational flying time of the drones and make it so that they're fully electrical and more sustainable to be used. But that's dependent on the new technologies and funding in order to be able to pay for these new sustainable technologies. But yes, about an hour operational time of 16 kilometers.
Thank you. We also get some very professional questions.
Yeah.
Yeah, from Goncalo. Does the system also work for basic or demersal species? And for pelagic species, what is the maximum depth for detection?
Yeah. Well, so for pelagic, yes, right now the depth that we're testing it at is the depth that the fishermen fish at, which is around 70 meters maximum. But depending on the power of the echo sounder, that will be what determines the depth that it can detect at, right? Because a more powerful, lower lower frequency waves will be able to detect further down than higher frequency waves. And so that'll just be a case of adjusting the echo sounder parameters for the depth that you would like. In terms of benthic demersal species, that might require, for this drone that we are currently developing, this first prototype, I don't think that benthic and demersal species will be possible, just because of the quality of the echo sounder that we're using in this first prototype. But it doesn't mean that later on, again, with further funding, changing the sensors that the drone deploys, we will definitely allow for benthic and demersal species, but will require obviously a dedicated sensor, echo sounder, hopefully one day sonar for that. But yes, the echo sounder will detect everything in the water column. So pelagic fish for sure, hopefully soon benthic and demersal as well.
And a question from Stephen: what sensors are entered into the water?
Yeah, so right now our payload is just an echo sounder. We had hoped to be able to include a sonar, as the sonar provides a horizontal search, but unfortunately for the frequencies that we would need to use, it's too large for the drone to carry at this stage. And so right now we'll only be deploying an echo sounder. So it'll be a vertical search through the water column.
Thank you. And still from Stephen, is the drone on an automated path, or is it remotely controlled?
A bit of both. So the pilot will be able to select waypoints for the drone to travel. So it won't have to be manually controlled like a joystick and what you get the those store-bought drones to be. And so it'll have the ground control station where the pilot will be. He'll be able to select distinct waypoints, however, as a backup system in case of strong winds or for any reason, if it needs to be manually controlled through a joystick, that's also possible. No.
And from Hans, are there any feedback from the fishermen of how the catch was?
So at this stage, not yet, because we haven't had our first test flight. But in March, when we have our test flight, the idea is to collaborate with the fishermen for them to validate what the drone is collecting. So we'll be working in tandem, we'll collaborate with them, working in tandem as the drone flies out, lowers the payload and detects whatever's there. The fisherman will then, our fishing boat collaborator will then go to the area where the echo sounder was deployed and validate with the boat-based sensors what was there, what kind of catch it was, with the size of the catch, the type of species. And this will all throughout, we'll be collaborating closely with the fishermen, because this will help us with our machine learning algorithms. And the more data that we can put in, the quicker that we can turn this whole system autonomous and more reliable. So right now there is no feedback, but hopefully end of March, April, there will be feedback.
Thanks. And from Ivana, what were the limitations for drone flight? For example, can wind strength limit?
So yeah, limitations for the drone. Wind strength is obviously a very big limitation. It's a very big drone. It's 2.6 meters diameter. So it's not those small flimsy ones that you obviously buy in the shop. So it can handle some wind. It is, I believe, up to sea state 6, Beaufort 6, sorry. It can handle, but that's just emergency only. And so, but obviously wind is a strong limitation. Distance, in terms of radio frequency, being able to communicate with the drone and transfer the data back. I think one of our biggest limitations is that the engine and the communication systems. That's what's hindering us being able to go a lot further as we would like. But yes, obviously wind, rain as well. Obviously we won't be flying out in storms. But also the fishermen won't be going out in storms, and so it wouldn't be needed at this stage. Maybe at a later stage we'll have a very robust drone that can handle storms as well.
Yeah. And Stephen asked, will the system also include aerial imagery or only payload sensors?
Yes, absolutely. We will have a camera on the drone which will look for surface-related indicators. So it'll look to see where there are seabirds, because that's often an indicator of fish presence. It will look to see agitation in the water, of also an indicator of fish close to the surface. But also we'll be using the camera to monitor for other biodiversity at the surface, from cetaceans to sharks to sea migratory species. So yes, it'll have both a camera that will be able to provide pictures and video, and then the echo sounder payload.
Thank you. And we got not a question, but a comment from Sergio. Congratulations for the project and the technology, put technology on traditional activities such as fisheries. Well done. Yeah. So now I just read out this, the questions and comments, but then you can also raise hand and ask the questions. Are there any issues with flying a large number of drones along the coast as you envision? About, for example, permits, flight safety, conflicts with defense interests?
Yeah, well, you'd be surprised, as it's a very infant industry. There are, especially in Portugal, there aren't a lot of hurdles in place. As long our drone won't be flying very high, and so that will facilitate in terms of the flight permits. We'll be flying around 30 meters height. And often a lot of complications come when it's above 50 to 100 meters. But obviously, as more drones are flying out, there'll be increased restrictions and increased hurdles that we'll have to overcome. But at this stage, because it's so new, at least in Portugal, there aren't many restrictions in terms of, obviously we have to have permits to justify the flights and to allow the flights, but in terms of safety and things with other drones flying around, that hasn't been an issue. In terms of conflicts with defense and things, that's all radio frequencies, right? So we've had to have lots of meetings with the Portuguese Communications Authority to see what radio frequencies we're allowed to use for the drone communication, both to operate the drone and to transfer data over. Obviously, some frequency bands are restricted to television and radio, others are restricted to military use. And so, but there are specific bands that are available to for these types of projects, and that won't lead to interference with defense or with TV, because obviously those will have priority. But so far it's, there's a lot of paperwork, but not limiting issues at this stage, which is good.
Good to know. And another question, do you see the project as scalable?
Absolutely. Absolutely. Obviously, I try to think positive. No, but I'm very positive about this, especially if, as I'm hoping with our test flight in March and April, if it's as successful as I'm hoping it will be, I think this will be revolutionary to coastal fisheries around the world, not just in Peniche, Portugal, but it will really facilitate the fishermen's mode of operation. It'll help free up their time to gain new skills and create these sustainable coastal communities, as I mentioned earlier, but also to allow them to help combat ocean litter challenges and fish for ocean litter instead of fishing for more fish. And there's a lot of fishing communities around the coastal fishing communities around the world that would really benefit from this technology and from this service. At the end of the day, what we'll be providing is a service. The drone will belong to the PELADRONE project, and the clients, customers, be they fishermen, be they government officials or researchers at universities, will access this application and have this data lake that they can use for all sorts of ends. And so I definitely see this as scalable, with a fleet of drones nationwide and hopefully one day worldwide. Yeah.
Thank you. And Torsten, there is a question about the flying regulations. Flying uncrewed, is that an issue?
Yes, so the drone won't be necessarily flying uncrewed because it'll have a pilot. It won't be uncrewed per se, so it'll require a licensed pilot for this size of drone, for because it'll be going out of line of sight. It requires an additional license and additional qualifications. And so that all keeps within the flying regulations for the drone. And again, as it's a very infant industry around the world, really, these new regulations are coming in every month. And so, but at this stage, it's a case of being a qualified pilot for this size of drone and for this distance of flight. And so, and it's not considered uncrewed because it's piloted by somebody.
Thanks. And two questions from Adrian. Yeah. Oh, Adrian, do you want to ask them yourself?
Sure. Hey, Mafalda. Really interesting presentation and cool to hear an update from the project. I think we spoke in summer the last time. My one, in the summer, we also spoke about how to potentially detect the fish. My question is that done by a human operator who monitors the camera, or is it done automatically?
Yeah, at this stage, it'll be through a human operator because the technology doesn't yet exist for it to be automatic, but our goal is to turn the detection automatic. As more data is fed through from the drone and also validated by the fishermen, we hope in this next stage of the project, we hope to collaborate with universities that are researching exactly this, how to detect through echo sounder images and through camera images, the types of species that are being detected. But right now, yes, it'll be a manual human interaction to determine what the species and what it is that's being detected.
All right. And if I can, a second question.
Yeah, of course.
Looking at the overall picture, what do you think are the main technical challenges in this phase of the project?
Yeah, at this phase of the project, in my view, the biggest technical challenges are the battery and fuel capacity. I would ideally really like to limit fuel use because we want to turn this as sustainable and environmentally friendly product as possible. But obviously the technology doesn't yet exist for batteries capable of operating such a powerful equipment for such a long period of time at such a long duration. And so that, in my view, is one of the technical challenges. Obviously, the fact that these algorithms also are in their infancy, they're not fully developed at this stage, and so will require a lot of work to turn this autonomous. But I think the biggest challenge for the drone itself is definitely the fuel aspect of it, because that's limiting how far it can go and how long it can operate for. But then as a service itself will definitely be the algorithms are the biggest challenges at the moment, just because it's so new. A lot of people believe that this technology already exists, that the drone can go and already detect, oh, it's a herring, oh, it's a cod, but it doesn't. It's still being developed by PhD students and researchers around the world, and so which also makes it very exciting. And so it's a challenge, but an exciting challenge.
Yeah, sounds interesting. Thank you.
And Stephen, I saw you also post questions, but I'm not sure whether Mafalda, when she's addressing Adrian's question, has she also addressed your question? Stephen's question is, will the system...
I got the answers I wanted.
Great, yeah, great to know. Yeah, so Torsten, please.
Yes, I just want to start with saying, wow, big congratulations. This is simply amazing. And right now my head is sort of boiling over with ideas about how Ocean Data Factory Sweden can possibly contribute and support you in your work. And I will have to get back to you and take that conversation together with Robin, obviously, and several other people. Perhaps, and I also want to say this, I'm super glad that we have participants today here from SWAM, the Swedish Agency for Water and Marine Management. I hope you all listen very closely, because this is the future.
I agree.
And I want to raise one thing. and that is, I think there's a great prospect with combining what you are doing now with sensors from drones, with sensors on the fishing vessels' gears.
Yeah.
And that is also something that is happening around the world. We possibly can contribute with some connections there.
No, that'd be great. No, as I said, I probably said it too quickly. The idea is to create this data lake of ocean data collected from various sources, be it from satellite, be it from fishing vessels or general vessels, even recreational vessels all around the world, to really have it as abundant as possible, which will really help the development of these algorithms and just the machine learning processes of the service. I'd also really like to, at one stage, later down the line, include a citizen science layer where people can also be contributing with what they see when they're out on their sailing boats or when they're out going for walks along the coast. And so I think the more data sources that we can put into this, the better, for sure.
We would definitely love to follow up on all of these initiatives and ideas. So super.
Yeah.
Can I just share one thing, since I have all these people here? I think it is so exciting. Thank you so much for so many to show up. And Mafalda, that was a great presentation. Thank you. It's so wonderful to see things coming so far. And we have Sergio on board in the call as well, who's from is sitting in Peniche, who we've also been working with in this project. So along the way. So a big hand to Sergio as well, who's here. But a couple other things, if I could just share real quickly, because this just came hot off the presses. So if I could just share my screen quickly. I just want to show you something. This is really cool. You might wonder, what is this? What is this? Any ideas? Any ideas what this could be?
A share.
Yeah, exactly. Here it is. Let's see if I can find it there. The finished product of ocean plastic. So this is the idea is Peniche Ocean Watch is also part of creating a blue circular economy. And the idea is that as the fishermen are fishing more competitively and more sustainably, they will have also more time. And the idea is to be working with them. So we've collected today already 40 tons of ocean plastic, of fishing nets. Used fishing nets from the fishermen, and are working to, as you see, produce these. This was a 3D printed chair in Karlshamn, made out of fishing nets, and it's now in the office. It just arrived today here in Stockholm. So it's moving forward step by step, slowly but surely. I just wanted to. I was so excited because it just came in the door. So.
Thank you for sharing about that, Jovin. And yes, when the fishermen, they can have more time, they can do other things than just spending time on the sea and searching for fishes, less risk. And maybe they can also do creative things to help with the sustainability aspects. And we got another question from Gonzalo. Do you envision providing the PELADRONE service to the industrial fishing fleet? So it would make sense, I guess, but could risk widening their competitive edge relatively to smaller scale fisheries?
Yes, so at this stage, no, because as you say, it would risk widening the competitive edge. They already have access to such innovative technology because they have so much money invested in them. What I do envision is that industrial fishing companies might want to, but maybe this is me being very idealistic, might want to invest in this type of technology to help the little guys as part of their corporate social responsibilities, as part of, at the same time, offshore fishing, possibly, yes. For example, if they're not in competition with the coastal fishermen, for example, tuna fisheries around offshore, or cod fisheries offshore, as long as they're not competing with coastal fishermen, that might be a possibility that we will look into. But right now it's definitely focusing more on the coastal fishermen, the little guy, and also researchers and governments for their use of it, more so than giving the big industrial guys another tool at this stage. But Robin and Jan Erik might say otherwise. And so
I also have a question. What motivated the team to start with a project? And is that social justice, is that also an issue when you think about this project? Because you mentioned the competitive edges of the bigger industrial fishing companies and this small and medium scale fishermen.
Yeah, I believe Robin is definitely the best person to answer this, as Robin and Jan Erik were the two founders of this project and of this initiative, and I only came in at the beginning of the project when funding was already acquired. But and so I'll let Robin answer, but I believe, yes, it's very much this social justice, doing something that will help these coastal communities who so desperately need it. But I will let Robin answer something more succinctly as to how her passion came about this.
Yeah. Sorry, I'm just trying to find a place in the house where I can talk. I have people coming in and making lunch. Anyway, yeah, no, I think this should work. Yeah, the initiative behind this is just very much seeing how can we create coastal, enable coastal communities, as we say, to take back their future. And we've been working very much with creating this blue circular economy, and had a vision with this since 3.5 years back. Where how can we release trapped values in these coastal communities? Because our idea is they have a direct impact on the coastal community, and through that it'll have an indirect effect on the ocean. So we're taking a bit of a different approach than many others, where they're focusing more on, say, just cleaning up the ocean. But our idea is how can we improve social sustainability in coastal communities, create more jobs, and through that then we'll be able to be, have a direct focus or an indirect focus on the ocean as well. So that's, yeah. But it's also, I think, just about creating networks. We have so many incredible high-tech companies here in Sweden and Norway, and a focus on a circular economy. And it's really about, if we're going to, take on these global challenges, how do we leverage all our resources and create an ecosystem that can do that? And we found such openness and willingness in Peniche, and, come, let's work together, let's collaborate. Working together with these fishermen has been absolutely amazing. And I think, and working with the tech companies here in Sweden and Norway, also incredible. So there's so much desire and willpower to do this that, you come with a little idea and it's like, wow, let's just do this. And I think that's really, and then as you see the project growing, bringing in Mafalda, receiving money of Jan Erik over there. I don't know if you want to say a few words, Jan Erik, but I'll be quiet. Yeah. Guess he didn't want to say anything. He just wants to smile.
No, I what can I say? You said a lot, so, but it's as you say, we want to do something for a coastal community and bring on something of what we can bring on from where we come from. My role from the ocean world of technology, and Robin's from the digital and sustainable way of world, and we think Peniche Ocean Waters as such has just shown that it's been growing gradually when the more people get involved, and all these activities we are doing, and PELADRONE is like the most active right now, and we are very pleased now to see the drones come down there to fly in March and start to work with the fishermen and see the result of this initiative. So yeah, thank you, Mafalda. Great.
Thank you.
Thank you all.
Yeah. And we got some comments or question from Torsten. So to Swarm, how far away is the use of this type of data in official operational environmental monitoring? Yeah, Torsten, do you want to?
Well, I think I got at least one answer from someone who I think was working on Swarm, Gonzalo, but I'm not sure. But anyway, it's a sort of provocative question directed to the operational authorities. I know it's a super long way to get there, but I'm just going to tell you, we're going to get back to this.
Yeah, we're hopeful.
Yeah.
Hans from SWAM, could I answer, Torsten?
Yeah, please.
Yes.
That was a very, very interesting project. Thank you very much for a very good presentation. It's very inspiring. And we have a lot of challenges in SWAM, and right now we are going to have a pilot with the cameras on the fishing vessels.
Mm-hmm.
And in that instance, we would like to have more information from maybe Ocean Data Factory, what we can collaborate in and how we can use this. So we will come back to you, Torsten.
Great.
Thank you.
Any other comments or questions?
Feel free to also email if something comes up at a later date. Get in touch, and I'll happily reply. I'll happily obviously reply, but also can sit down and chat some more one-on-one if you'd like to know anything specific.
Yes.
And if anybody'd like to join the pilot in March, that would be great. If you'd like to come down and see Peniche, meet the fishermen, see what we're actually doing, you're more than welcome to come along.
I just shared the PELADRONE website through chat. Yeah. And also, of course, our Ocean Data Factory website. Let me also share the link. Okay. Thank you very much, Mafalda, Robin.
Thank you guys.
And our webinar series will continue next year. And actually, we have already scheduled 2 webinars, one in January and one in March. In the January one, our speaker will be Victor Anton, talking about how you leverage AI in wildlife preservation. And wildlife.ai is an NGO based in New Zealand. Yeah. So Mafalda shared about there are still challenges about recognizing things like whether it is herring or some other fishes, and the algorithm are still being developed. And maybe something that they do with other type of animals with AI can be also helpful. And in March, we will have Matthias Oft share with us about the Swedish biodiversity data infrastructure. And as we know, data is so important, and we hope to collect data and share data. And the biodiversity data infrastructure is one endeavor in this field. And he will share with us about the story and also this infrastructure. Yeah. Thank you very much. And I look forward to seeing you again in our coming ODF webinars. And if you have any questions or comments, please feel free to email or contact us. Yeah, thank you. Yeah. Oh, Torsten, Robin, do you want to add anything? Yeah.
It was wonderful.
Christmas. Yes.
Thanks a lot, Yishin, for sharing.
Thank you.
Yeah, thank
Well
you so
done.
much.
Thank you, Mafalda and Yishin. Well done. Super.
Thanks for having me. Have a
Thank
good
you.
day.
Have a great
Yes.
day. Ciao.
Yeah.
Bye.
Bye.
Bye. Take care.